In this video, we want to find a formula for the integral of secant to the n power x dx for n greater than or equal to 2. So we're going to break this up first. We're going to have secant raised to the n minus 2 times secant squared. And the reason I'm going to do this is because I'm going to use integration by parts, and I know how to take the antiderivative of secant squared, because that's just going to be tangent. So then I'm just going to be taking the derivative of secant raised to the n minus 2, which is going to be u here. So this one we have to bring down the exponent, subtract 1 in the exponent, and then take the derivative of secant, which is secant times tangent. The antiderivative of secant squared is tangent. So now we just do u times v minus integral v du. And so we get this expression. So now we have to do some work inside the integral. So I can factor out the n minus 2, and secant to the n minus 3 power times secant will just give me secant to the n minus 2 power. Okay. Now from here, I can break up tangent squared into secant squared minus 1. And the reason I can do that is because tangent squared plus 1 is secant squared. So if I subtract both sides by 1, I get tangent squared is secant squared minus 1. Now I'm going to distribute the secant to the n minus 2 power. And so I have secant to the n power minus secant to the n minus 2 power. And so recall that this is equal to the original integral, which is secant to the n power. So now I'm going to break up this integral here into 2. So think of it as like distributing the n minus 2 to both pieces and then breaking it up into 2 separate integrals. So recall that this is a minus, so this will be minus n minus 2 times the integral of secant to the nth power. And then a minus and a minus gives me a plus, and then n minus 2 times the integral secant to the n minus 2 power. Now I can add the n minus 2 times integral secant x dx to both sides. So this, think of it as like a coefficient of 1. So you do 1 plus and then n minus 2. So this guy right here. That's going to give us n minus 1. Okay, so that's what is over here. Everything else stays the same. And at this point, we just need to solve for integral of secant to the nth power. So we're going to divide everything by n minus 1. And when we do that, we end up with this formula right here. Now, we can use this formula to solve for secant, the integral of secant to the 4th x dx. And obviously here, n is going to be 4. So you plug it into this formula. We get it down to this, so we have secant squared times tangent x over 3 plus 2/3 times the integral of secant squared. And we know the antiderivative of secant squared is tangent of x. And so this is our final answer.